Often we don't notice it's even there, but it's all around us. It's in our environment, it's in our water, it's in our homes, our streets, and our food. It is at the center of new technology, new forms of energy, new ways to fight disease, and new ways to solve the problems we all face together. It is every day, and it is life changing. It is the future. Often we don't notice it's even there, but it's all around us. It's in our environment, it's in our water, it's in our homes, our streets, and our food. It is at the center of new technology, new forms of energy, new ways to fight disease, and new ways to solve the problems we all face together. It is every day, and it is life changing. It is the future.
Hello. Uh, Good evening, right? I think there's a lot of rain, but I hope you can hear me, right? And see, let us try to work it out. Tutorial number 14. Do you have access to it? I hope you have it. Tutorial number 14, we'll finish it, right? So remember tutorial number 14, I did it up to question number 5 last week. Last week, we did it up to question number 5 last week. Huh? Right? I hope you can hear me, right? Up to question number 5. Now let us continue from question number 6. Question number 6. Is it okay? Everybody all right? Were you able to hear me? Everybody? Right. Can you confirm that? Right. Yeah. So lots of rain. Shall we start? All of you can hear me well. Is it raining there also? Right. Okay. Okay. Right. So question number 6. Right. Question number 6. A, B, C, D are non-transient elements. So that means it is the main group elements, S block elements and P block elements. Having atomic numbers Z, Z1, Z plus 1, Z plus 2, Z plus 3. That means they are consecutive elements in the periodic table. Consecutive elements in the periodic table. And the highest first ionization energy is observed for element C. So if you look at the first ionization energy, this is how it works. Right? It works like this. First ionization energy, right? If you look at it like that, up and then down. Next one is up, down again. And then you get up and up. And the next one is down again. Is that the first element in the next period? So you get it like this. And then it goes over here. Right. So this is group 1, this is group 2, this will be group 13, 14, 15, then 16, 17, 18. And this is the next group, right? Next period, group 1. So this is how the first ionization energy varies. This is the element. Right? Okay. So let us see. It says, observed for the element C, highest first ionization energy is observed for element C. So there are two options you can come up with. What is this? First one is you can say this one is A, this is B, this is C, and this is D. Right? Highest first ionization energy means you have to have the highest value for C. So it might be this 13, 14, 15, 16. Or else you might have this other one. You can have A might be this, B might be this, C might be this, D might be this. So these are the two options you can have. In both of these options, you get C as the maximum first ionization energy, A, B, C, D. A, B, C, D, first ionization energy is maximum. Right. Explain to which group C belongs to if the atomic radius of D is less than that of C. So let us look at the red option. Let us look at the red option. If you look at the red option, A, B, C, D belongs to the same period. 13, 14, 15, 16. And if you look at the atomic radius 13 is higher, 14 is lower, 15 is even lower, 16 is even lower. Across the period, atomic radius decreases. So it says atomic radius of D is less than C. Right? D is less than C. But if you look at the blue option, I can see some questions. I will look at them after discussing this, right? Look at the blue option. Blue option C is group 18 and group 1. Group 1 has a very high radius because it is a new period as well. So if you look at this one, D has the highest radius and then A, B, C. So if the atomic radius of D is less than C, it belongs to this. What is the group that belongs to C? C belongs to 15, group 15. Huh? Group 15. If the atomic radius C is less than D, then C belongs to group 18. This is the group that you have. Group 15 and group 18. Ah, right. Good. You have given answers. Very good. Very good. I hope you understood that. Now let us go to the next page. Next page. Next page. Tell me if it is right, real. The rain is, if it is really disturbing, tell me, right? Question number 7. Right. See, let us see how this is going to work. The variation of the first 8 successive ionization energies of element X, which is in the 4th period, is given below. So this belongs to the 4th period. That means the last energy level is 4, right? And it belongs to the 4th period, and they have given a diagram like this. But in this first electron, second electron, third electron, fourth electron, fifth electron, sixth electron, then you get the 7th electron, you get eighth electron. So like that. Like this. That's how the variation takes place. That means you have removed how many electrons from the outermost energy level. There's a huge gap. How many electrons are removed from the outermost energy level? You have 1, 2, 3, 4, 5, 6. 6 electrons are removed from the outermost energy levels. Yes. So I'll write 6 electrons are removed from the outermost energy level. From outermost energy level. Right. 6 electrons are removed from the outermost energy level. That means it belongs to which group? What is the group number? Can somebody tell me? Very good. I can see a lot of correct answers. Yeah. But what is the group number? When you say group number, is it group 16? Yes, group 16. It belongs to group 16. Right. So explain to which group element X belongs to. You have removed 6 electrons from the outermost energy level. Therefore, last energy level contains 6 electrons. That means it belongs to group 16. So you can say last energy level contains 6 electrons. So therefore, group 16. Group 16. Right. Write down the complete electronic configuration of element X. How do you write the electronic configuration? Right? There's nothing called group 6. There's nothing called group 6. Group 6 was there in your O levels. Now we say group 16. Right? That's how you name it. You don't have group 6 in make it. Another 6 කියලා කියන්නේ නැහැ. This is like group 16. That's how you get it, right? So P4 is the electronic configuration. P4 electronic configuration, S2P4. So P4, 4 plus 12. That's how you get the group number 16. Right. So how do you write the electronic configuration? You have to fill it up to the 4th energy level. Why do you say that it belongs to the 4th energy level? Because it belongs to the 4th period. So the last energy level should be 4. So we say 1s2, 2s2, then 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. I think that is the electronic configuration that you get. What do you say? Do you agree with that? Or you have any other answer? Right. Okay. Everybody agrees with that. Right? Okay. I didn't get the graph of question number 7 and the group identification of the group identification of S කියලා කියන්නේ පුතා, like you are removing 6 electrons. These are successive ionization energies. 6 after removing 6 electrons, when you remove the 7th electron, you are breaking the octet. That means there are 6 electrons at the outermost energy level. 6 electrons means S2P4 configuration. S2P4 configuration means for the P, you add 12. I think we have done this. This is like a summary questions from all the set of questions there, right? Okay. It will say, determine the main valencies of element X. What are the main valencies of element X? Group 16. What are the main valencies? Group 16 valencies are 2, you can have 4 and you can have 6. 2, 4, 6 are the valencies that you get. Right? Did you understand that? 2, 4, 6 are the valencies. Very good. I gave you these answers. Please make sure to look at that, revise that one last time before we actually do all the other things, right? 2, 4, 6. By using the correct symbol for the element, write the hydride formed by the lowest valency of the element and write the formula of the oxide formed by the highest valency. Yeah. What is the element? Can you tell me what is the element? Right? This is group 16, oxygen, sulfur, selenium, tellurium, polonium. These are the elements in group 16. Right? This is period number 2, this is period number 3, this is period number 4, 5 and 6. So our element is selenium. This is our element. Right? Okay, so what do they ask? Write the hydride formed by the lowest valency. Lowest valency is 2. But hydrogen is 1, hydrogen valency is 1, selenium valency is 2. So exchange the valencies. So you can say H2SE and H2SC, right? Lowest valency of the element and write the formula of the oxide formed by the highest valency. What is the formula of the oxide? Highest valency is 6. So oxygen is 2. Selenium is 6. Exchange the valencies. So SC2O6. But we can simplify. So you get SeO3. Did you understand SC? But do you simplify? Like, when you have anything that you can simplify, you simplify it. Did you understand that? Everybody? Right? Okay. Right? Is it clear? Right. Okay. Then somebody asked me, how do you get the valency 4? Because there are 4s2, 4p4. 4s2, 4p4. By removing these 4 electrons, you get a valency of 4. Right? There are multiple valencies it can have. Right. Shall we go to question number 8? Question number 8. Right. Let's see. Right. Okay. So let us start looking at that. Right. X, Y, Z are 3 consecutive elements. That means they are located among each other, right? One after another, right? X, Y, Z consecutive elements in the periodic table and non-transient elements. They belong to main group elements. The variation of the first ionization energy is given below, right? So, and they have given something like this. X is somewhere here, Y is somewhere there, and Z is somewhere here. X, this is Y, this is Z. Right? So you have a variation like this. So what is this variation? This is the first ionization energy. That's a very important thing. This is the I1E, first ionization energy, X, Y, Z. If Z is a gas at room temperature, right? Okay, so you can see there's a peak and there's a drop, right? So how does the variation take place in the first ionization energy? You remember this, right? Up, down, then up, down, then up, then up. Kemudian usually this is how the variation takes. Group 1, group 2, this is group 13, 14, 15. And this is 16, 17 and 18. That is how the group numbers goes, right? For the main group, right? Then they say, now, now it says now you can see in X, Y, Z, there is a going up and down. So you can have this option. Option, you can have X, Y, Z like this. Right? Or you can have the red option, X, Y, Z like this. right? But can you have now after the 18, this is group 1. Can you have X, Y, Z like this? The green option, can you have? Can you have the green option? Can you have the green option? No, you can't have the green option at all, right? Why can't you have the green option? Why? Because you can see Z is less than X. But here Z is between X and Y, right? So you can't have the green option. Nah? So I will say can't have the green option. Can't have the green option. Right? You can have only the black option or and the red option. These are the two things that you have, right? It says Z is a gas at room temperature. Now look at Z. What are Z? Z can be group 13. What are the elements in group 13? If Z is group 13, what are the elements in group 13? Boron, aluminium, gallium, indium, thallium. None of them are gases. I told you there are only 11 gases in the periodic table. What are the 11 gases? Can you type it? Hydrogen, oxygen, nitrogen, fluorine, chlorine, see? Neon, argon, xenon, krypton, radon. Yeah. And hydrogen, helium, and helium. So there are 11 gases. So this should be a gas. No gases in group 13. Do you have gases in group 16? Group 16, do you have gases? No, either Z can be group 13 or group 16. Can you have gases in group 16? Can you have gases in group 16? Yes, you have oxygen. Oxygen is a gas. So this should belong to this red option is the right option. Right. So Z can be oxygen. Right. If Z is a gas, then deduce the element X. If Z is oxygen, X is what? Carbon, nitrogen, oxygen. Carbon, nitrogen, and oxygen. So oxygen, Z is oxygen. So therefore, Y should be nitrogen, and therefore X should be carbon. Carbon is the material. Right. Write the electronic configuration of X. X is equal to 1s2, 2s2, 2p2. I can see some of those questions you have asked. I will reply them. Huh? Write the electronic configuration of the element just below Y in the same group. How the Y? Y is nitrogen. Just below Y, you get phosphorus. Y, below Y, you get phosphorus. 1s2, 2s2, 2p6. 3s2, 3p3. I hope you understood that. Explain the variation of the electronegativity of X, Y, Z. Across the period, electronegativity increases. Across the period. So X, Y, Z, Z has the highest electronegativity, then have Y, then you have X. Let us see what are the questions you have. There are some people have written the answers are good. They are correct answers, but I saw some questions. How did you take 2 for selenium? I put that 2 thing. If you look at S2P4 configuration, you can take 2 electrons. You can take 2 electrons. Valence is the either the number of electrons that are given out or taken in. So you can have valency too. Then you can look at the selenium. Selenium, you can have a bond here, right? 1, 2, 3, 4. What is the valency? Here you have participated in one bond and then the second bond. So valency can be 2. That is how you get valency 2. Very good. I like the answers. How the graph in the second ionization? In the second ionization energy, they didn't ask. But graph in the second ionization energy shifted one element to the left-hand side. Or that not second ionization energy is highest for the group 1 elements. ඔය graph එකම තමයි. Right? තේරුණාද? Right. Okay. . . Right, okay. හරි. ඊට පස්සේ අපි බලමු and explain the variation of the electronegativity. So this is how the variation take place and they ask you to explain. How can you explain the variation? What is that? When you go across the period, what will happen? Effective nuclear charge, ZEFF, effective nuclear charge increases. Radius decreases. Therefore, ability to attract electrons increases. Right, okay. Now I will go to the next tutorial. Next tutorial is tutorial number 15. Tutorial number 15. Okay, so tutorial 15. So that will end that section. All the tutorials are done. You can now start working on it and then we can do an exam also. So, right, okay, right. But on tutorial number 15, A, B, C, D, E are having atomic numbers Z plus 1, Z plus 2, Z plus 3, Z plus 4 and non-transient elements. They don't belong to D block elements. That is what we mean by that. They are not D block elements. They belong to S and P. That's all, right? Right. So they are non-transient elements. The variation of the first ionization energies are given below, right? So what do they give? They give you the variation of the first ionization energy. First ionization energy variation is like this. A, this is B, this is C, D and E. This is how the variation they have given. Right? A, B, then you get C, D and E. That's the variation that they have given. Now, in order to keep a track, it's always better to draw your first ionization energy variation. 1, 2, 3, 4, 5, 6, 7, 8. That's how the variation takes place. This is the variation. Right? Right, 1, 2, this is 13, 14, 15, 16, 17, 18. Right now. Now, what does it look like? Which part of the diagram is this? One is going up, down, up, up. Up, down, up, up. Up, down, up, up. It can be something like this. This part. Right? Or else you can have it as this one. Like this. So there are two options. One is the blue option, other one is the pink option. You can see the same variation. If the oxide of A shows acidic properties, how the oxide of A shows acidic properties. Acidic means non-metal oxides are acidic. Metal oxides are basic. Metal oxides are basic. Oxides are basic. Non-metal oxides are acidic. Non-metal oxides are acidic. Then ඔයා දන්නවනේ carbon dioxide is acidic. Non-metal oxides are acidic. So therefore, your compound A or element A should be a non-metal. Right? Element A should be a non-metal. Right? So what is element A? Element A is this one. Right? You can't have element A in group 1. Right? Element A cannot be group 1 because group 1 is always a metal. Metal oxides are basic. So we say group 15, right? So therefore, this A, B, C, D, E are 15, 16, 17, 15, 16, 17, A, B, C, D, E. So yeah, 14, 15. 14, 15, 16, 17, 18. I will erase that and do it for the people who look at this diagram. This will be 14, 15, 16, 17, 18. So it should be a non-metal oxide. What about amphoteric? They are both act as oxide, acidic, and amphoteric means they are acting as acidic or basic. They have both properties. Right, okay. So 14, 15, 16, 17, 18. That is what you have. Right, okay. Right. But again, can you explain the first part of this question again? Which part? First part එක තමයි කරන්නේ, right? So you get 14, 15, 16, 17, 18. You can have 1, 2, 13, 14, 15 or 14, 15, 16, 17, 18. So out of that, these elements belong to 14, 15, 16, 17, 18. 18. Right. If the oxide A shows acidic properties, right? Then write down the chemical formula of the compound which is formed with hydrogen. Right. So A belongs to group 14. What is the valency? Group 14. Can you tell me what is the valency? What is the valency? If it is group 14. If it is group 14, what is the valency? Right? You can have 4, right? Carbon, those kinds of things. So valency is 4, right? So chemical formula of the compound which is formed with hydrogen. So A and hydrogen. A has a valency of 4, hydrogen has a valency of 1. How do you get the structure? You exchange the valencies. You get the formula AH4 කියලා එනවා. AH4 is the answer. Did you understand that? AH4, right? Good answers. Then they don't say which like which elements කියලා කියන්නේ නැහැ, right? That's what. AH4. You can't actually predict which period it belongs to, based on this. It doesn't say anything there, right? Right, okay, right. What is the element that shows the maximum covalent radius? What is the element that shows the maximum covalent radius? Across the period, what happened to the radius? Across the period. Across the period, what happened to the radius? Radius decreases. Decreases. If it is across the period, if the radius decreases, which one has the highest radius? Highest radius is for A. Right? A has the highest radius. Draw the dot diagram for the compound formed with the reaction of A and bromine. A has a valency of 4. Br has a valency of 1. So what is the compound that you get? You get ABr4. So how do you explain that? A is there. You get a Br here. You get a Br here. You get a Br here. You get another Br over here. Bromine contains 7 electrons. Now you know how to write Lewis structures and all. So this is how you get those. But they ask you to write the dot diagram. Dot diagram, you draw dots here. Every dash is represented by a dot. If there are any parts that you didn't understand, right? Make sure to ask that. Okay, right. So that is your ABR4. Right, good. Okay. AB2 என்னன்னு පුතා? A is a valency or has a valency of 4. A has a valency of 4. Not AB2. A has a valency of 4. Bromine has a valency of 1. So when you exchange this, you get ABR4. If you want to, if you don't understand it, you think about it like this. A is like carbon. Carbon has a valency of 4. Bromine has a valency of 1. So carbon CBr4. That's the compound. Not ABr2, ABr4 is the compound. Right? So I'm going to erase this part, right? Everybody okay with that? Any questions you need to ask? Anything that you didn't understand or anything? You need to ask. මොකද්ද පුතා, can you explain the third question? කියන්නේ මොකද්ද ඔයාට ඒකේ තේරුම් නැත්තේ? Which part you didn't understand? Draw the dot diagram for the කියන්නේ Lewis structure. Draw the Lewis structure. Lewis structures are also called dot cross diagrams, dot dash diagrams. Dot diagram for the compound formed with the reaction of A and bromine. So A has a valency of 4. A කියලා හිතන්නකො carbon කියලා. Bromine has a valency of 1. So you exchange the valencies. ABr4. Is it clear? If they ask to draw the Lewis structure, should we draw according to the electron pair geometry? No, you don't have to. Lewis structure doesn't say anything about the electron pair geometry. Yeah? Right. All right. Okay. Everybody okay with that? Anything that you didn't understand or you want me to explain again? Right. Okay. Because Lewis structure doesn't say what the structure looks like. Right? So in the paper, there is bromine, something is it a printing mistake? A bromine is bromine, it's diatomic species. Bromine exists as this. Its valency is 1. Smallest, simplest valency is 1. Yeah, bromine, Br2 exists as Br2. Like hydrogen, just like hydrogen exists as H2. Nitrogen exists as N2, oxygen exists as O2, fluorine exists as F2, chlorine exists as Cl2, bromine exists as Br2. Right, Br2 is, that is how it exists. It exists as a diatomic species. 2 atoms connected together. Right. Everybody okay? Yeah. Question says bromine. Bromine තියෙන විදිහ තියෙන්න එපා. Hydrogen doesn't exist as hydrogen atoms. Hydrogen exists as H2. Right. How do you identify the simple valency? I have given them. Right. I have given them. Right. Right. Let's go to the second question. Right. Second question. Let's look at the second question. Now tell me, how do you think about these things? Right. The second ionization energy is lowest in group 2 elements. What do you think? Is it a right statement or a wrong statement? What do you think? What is your answer to this? True statement or a false statement? Second ionization energy is lowest for group 2 elements. That's a true statement. Isn't it right? Because you need to, like, same variation of the same first ionization energy, you move to this side, to the left-hand side. So A is a right statement. Right. Okay. Right. Okay. Second ionization energy is lowest for the group 1 elements. Very good. All elements have a second ionization energy. What do you think? All elements have a second ionization energy. Answer is no. Hydrogen doesn't have a second ionization energy. Yes. So no, hydrogen does not have. Right. Okay. Good. So that is B. C. Second ionization energy of an element is always greater than the first ionization energy. Again, second ionization energy of an element is always greater than the first ionization energy. Yes, true. True statement. Why? Because the effective nuclear charge increases. When you remove an electron, in order to remove the next electron, you need to supply a higher amount of energy. That's a true state. D. Second ionization energies are always endothermic. Again, all ionization energies are endothermic, right? Because you need to break the intermolecular forces. So that's a true statement as well. You need to break the internuclear forces. the first ionization energies of D block elements generally increases. That is also true. D block elements gradually increases because of the increase in the effective nuclear charge. Right? Now, if you look at scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, in this direction, effective nuclear charge gradually increases. So generally, there is a kind of a slight increase when you go across. So E is right. F. The radius of elements in the period increases across the period due to the increase in the effective nuclear charge. Radius of the period increases across the period. Radius increases. No, across the period, when you are going from the left-hand side to the right-hand side, it decreases because of the effective nuclear charge increases. Right. Copper has a lower first ionization energy than zinc. Actually, zinc, I think slightly lower. We will talk about this later, right? It comes under a different chapter. We will, for the moment, we will leave it like that, right? Ability of an atom to attract electrons towards itself in a bond is known as electronegativity. What do you think? EFG. Well, again, is it a true statement or a false statement? Ability to attract electrons towards the atom while it is in a bond. I think that's a true statement, right? The electronegativity of an atom depends on the environment of that atom as well. That is also a true statement. It depends on the environment also. What are the other elements that are there? That also depends. Now, for example, let us say you have a carbon here, and let us say you have a chlorine, something like bromine, and then there is chlorine here, and then chlorine here. And then let us say carbon and bromine, there is fluorine here. Fluorine here, fluorine here. Now you can see the environment is different. What are the other atoms that are there? Chlorine withdraws electrons little less compared to fluorine. So now what will happen is these electrons are highly withdrawn towards that. Highly withdrawn towards that. So because of that, electronegativity, the electronegativity of an atom depends on the environment. That is a true statement. J. Electronegativity decreases as the radius of the atom increases. Electronegativity decreases as the radius of the atom increases. When you are going down the group of a period, the atoms become bigger. And electronegativity, what happens? It decreases, right? Beryllium has the highest electronegativity out of the S block elements. Yes. If you look at the S block elements, group 1, group 1, group 2, lithium, beryllium, boron, carbon, sorry, we will look at it in downwards. Lithium, sodium, potassium, rubidium, cesium. Right? Beryllium, magnesium, calcium, strontium, barium. When you are going down the group, electronegativity decreases. So highest electronegativity values are in lithium and beryllium. When you go across the period, electronegativity increases. Electronegativity increases. So therefore, beryllium has the highest electronegativity of S block elements. So K is right. Electronegativity increases when going down the group. What do you think? Electronegativity increases when going down the group. Electronegativity, hydrogen is not considered as a S block element. Right? Hydrogen is not considered as a S block element. Api S block elements kila kiyanne naha hydrogen. Right? Electronegativity increases when going down the group. Right. Maximum electronegativity, electronegativity increases when going down the group. That is wrong. L is wrong. Electronegativity decreases. Maximum electronegativity is for elements in group 17. True. M is true. There is a zero electronegativity for group 18 elements. there is a zero electronegativity for group 18 elements. What do you think? It's a false statement. N is a false statement. It has a lower electronegativity, but you don't consider it as a another zero. It has certain value, but it has a very, very low electronegativity. Sometimes it is not defined, but it is not considered as zero, right? Why, sir, hydrogen does not consider it as a S block element? I think I have given you the reasons. Hydrogen, like very last part of this, I have given why hydrogen has a kind of a issue. Hydrogen behaves like hydrogen exists as a diatomic species. So it looks like group 17 elements, right? It can have negative oxidation state, negative charges it can accumulate. So therefore it looks like a group 17 element as well. Hydrogen is not behaving as the other elements in the S block, because other elements are metals, solids. Hydrogen is a gas. So there is a little bit of ambiguity. So hydrogen, you don't consider it as a S block elements, right? It අපි ඔක ගැන කතා කරා, right? Okay. Xenon 2.6 xenon වල ඇති වැලියවා but we don't consider it as zero, right? Question number 3, okay. Shall we go to the next one? You taught hydrogen when discussing S block in the SP. Yeah, it should like you have to have it. There is a place for hydrogen. Hydrogen, there should be a place, right? So it is at the moment it is given in the one according to the atomic number, but it is not an S block element, right? Question number 3. Right. Shall we go? Shall we do that? Question number 3. Right. 8 successive ionization energies of an element X are shown below. Right. So there's 8. The hydrogen, when you write the electronic configuration, last electron falls into a sub-energy level. So therefore, it is classified there, but it is not a S block. It is not. We don't consider it as a S block element because it is not a metal, right? Right, Harry? Okay. Everybody okay with that? Then which group hydrogen belongs to? At the moment, it is located in the S block, but it is not considered as a proper S block element. Right. So that's why we don't consider it as when you're considering metals. Beryllium has the highest electronegativity there, right? Okay. 8 successive ionization energies of the element are shown here, right? So 1, 2, next one, right? 3, 4, 5, 6, 7, and then 8. Right, okay? Yeah. So this is how the variation take place. After removing 1, 2, 3, 4, 5, 6, you see a significantly large increase, right? Okay. So that means it belongs to which group? There are how many electrons at the outermost energy level? How many electrons at the outermost energy level? How many electrons at the outermost energy level? 6 electrons at the outermost energy level. 6 electrons means what is the group number? Group number? Can somebody tell me what is the group number? If it is 6 electrons, what is the group number? Group number is what? 16. Group number 6 name. Group number 16. Group number should be 16. 14 name. Group number 16. There are 6 electrons only. There's only 6 electrons. 6 electrons means S2P4. For the P number of electrons, 4, you add 12. So that will give you 16. Everybody okay with that? Right? Typing error. Right, okay. Okay, right. Okay, good. So group number 16. Explain the variation of the first successive ionization energies as shown in the diagram below, right? So it belongs to group number 16. Common electronic configuration is inert gas. Configuration NS2 NP6. NP4. So when you remove 6 electrons, you are breaking the inert gas configuration. After removing 6 electrons, you are breaking the inert gas configuration. When you are breaking the inert gas configuration, you have a significantly high increase. There's a very high increase, right? So after breaking the inert gas configuration, uh, after breaking the inert, after removing 6 electrons, breaking the inert gas configuration needs large amount of energy. So that's why there is a significantly high increase in the energy after removing 6 electrons. That's why we say deduce the group number to which element belong to group 16. The element possesses an atomic number below 30 and its hydride is gaseous at a room temperature. Identify X. Hari balan. Group number 16. Can you tell me what are the elements in group number 16? You can look at a periodic table. What are the elements in group number 16? What are the elements in group number 16? What are the elements in group number 16? Elements කියන්න බලන්න. Elements in group number 16. Elements in group number 16. What are the elements in group number 16? You get oxygen, sulfur, selenium, tellurium, polonium. These are the elements in group number 16, right? Deduce the group. The element possesses an atomic number below 30. Below 30. So that means oxygen, sulfur. Atomic number below 30 means oxygen, sulfur. Its hydride is gaseous at room temperature. What is the hydride of oxygen? H2O. What is the hydride of sulfur? H2S. Then hydrogen is 1, oxygen is 2. Exchange the valencies. H2O. Why that? Hydrogen and sulfur, hydrogen is 1, sulfur is 2. Exchange the valencies. H2S. Right? So out of this, which one is the gas? H2O or H2S? Very good. Which one is the gas? Hydrogen sulfide is the gas. Water is definitely a liquid, right? Water is definitely a liquid. So hydrogen sulfide is the gas. This is the gas. Hydrogen sulfide is a gas that gives a foul odor, right? Foul odor, right? Identify X. Hydride gas is at room temperature. Identify X. X is sulfur, right? If there are allotropic forms of X, give their allotropic forms. Now that I haven't taught you, right? Right? But then you can we will learn this. So there are allotropic forms. These allotropic forms are called rhombic sulfur කියලා තියෙනවා. Rhombic sulfur. Don't worry, even if you don't know it now, ඒක ගැන worry වෙන්න එපා. We will learn it later. It's an exam question. So that is why I have given it. Rather than removing any of those parts. Rhombic sulfur. Then there is something called monoclinic sulfur. Monoclinic sulfur. Then there is something called colloidal sulfur. Colloidal sulfur. I think if you want, you can write it in that answer. Answer scheme එකේ නිකන් ලියන්න. Right? There are allotropic forms. Allotropic forms are like same elemental form. They have different ways of connecting. The best example you have learned in your O levels. Diamond and graphite. They are called allotropic forms. They all contains carbon. but how they are connected is different. How they have connected is different. They are called allotropic forms. Same type, but different ways of connection. So rhombic sulfur, monoclinic sulfur, colloidal sulfur, there's something called plastic sulfur, and then there's something also called milk of sulfur. If depending on their type, they have different names that are given. Right. Somebody asked me, what if we write crystalline and amorphous? Same anyway. All of these are crystalline structures that you get, except plastic sulfur. So rhombic, monoclinic, colloidal, plastic, and milk of sulfur. These are the allotropic forms. All right. Give the oxidation state X might have and give example for these 6 oxidation states. Now that also I haven't done. Whenever we start electronegativity very soon, within like another 2 weeks, we will do oxidation numbers also. Oxidation numbers, oxidation number means the valency, depending on whether the electrons are given out or whether the electrons are taken in, you can have positive and negative numbers. That is what is called oxidation numbers. But don't worry about it. For the moment, within like another 2 weeks, we will do that, oxidation numbers. So we'll properly learn and write an answer. I think that is better. Right. But question number 4, if we have time, that we have 9 minutes. Explain the following observations. Br minus has a bigger radius than Br. Right. So what is this? Br minus and then Br. Right. So some number of protons and some number of electrons. How many protons, how many electrons? Look at the periodic table. 35 protons. Here also 35 protons. How many electrons? 36 electrons. And here you have 35 electrons. Right? So here extra electrons are there. Extra electrons. So electron-electron repulsion makes it larger. Makes it larger. That is the next one. Sodium has a bigger radius than sodium plus. The sodium has a bigger radius than sodium plus. How many protons? 11 protons. 11 protons. But 11 electrons, 10 electrons. Right? 11. So here each electron is attracted. Each electron is attracted by a greater charge. Greater charge of the nucleus. Will summarize it. Sodium plus. Whenever you want to compare the radius, you have 3 things. What are the 3 things? Energy levels, number of protons, and number of electrons. Energy levels here, sodium is 3, sodium plus is 2. Why? Because you have removed the last electron. Number of protons are 11, number of protons are 11, electrons are 11, electrons are 10. So number of energy levels also goes down. And for each electron, there is a higher number of protons attracted. Net charge is high, not higher number, net charge is high. So therefore, radius is sodium, radius of sodium is larger than radius of sodium plus. Right. Question number 5. Let's look at the question number 5 also. Right. I'm looking at some of those answers again. Right. Number of protons and number of neutrons. Neutrons have no effect. Number of neutrons doesn't have a. Water vapor is when you get the vapor when you have a higher temperature, right? Higher temperature and water vapor, you get it at a higher temperature, right? You know, anything that you can convert it to gas. Sodium chloride also you can convert it to gas if you can come up to that temperature. Anyway, this is we are talking about room temperature. The hydride is a gaseous at the room temperature. Room temperature, water vapor. The water is not existing as the vapor, right? No, normally water exists in the liquid form. So you don't consider water vapor. This is about the earlier question. Right. Right. Okay. I'm just looking at some of those answers. Carbon have only two allotropic forms by the way. Carbon also have so many allotropic forms. You have the basic allotropic forms, diamond and graphite. Then you have this some graphene sheets. That's also allotropic form. Carbon nanotubes, allotropic forms. Buckyballs or fluorines, again, it's like a football. They are also allotropic forms, right? They are also having the same kind of thing, but different structures, right? Okay. X is a non-transient element that produces a molecular formula XF3. XF3. What is the valency of X? What is the valency of X? You can see, normally you exchange the valencies. The valency of X is 3. That is where valency is. Good, very good. Very good. Right. When it combines with fluorine, deduce to which group element X belongs to. What is the group that you can have? It can be group 13, or you can have group 15, right? Group 13 or group 15. Now, for example, group 13, aluminium, AlF3 වෙන්න පුළුවන්. Group 15, nitrogen, NF3 වෙන්නත් පුළුවන්. Right? Group 13 or group 15. The oxide X, X2O3, dissolves in aqueous sodium hydroxide. Oxide X, X2O3. ANA. Right? This one is 3, this one is 2. Valence is 2. Dissolves in aqueous sodium hydroxide. If it is dissolving in aqueous sodium hydroxide is a base. So that means X2O3 is an acid. Right? Group 13 is metals. Group 15 is non-metals. Non-metal oxides are the acids. Okay? Group 15 is a non-metal oxide. Non-metal oxides. I told you non-metal oxides are the acid. So therefore, X belongs to group 15. Don't worry about it too much. This is because it's the exam question. We will learn this. But you can handle it, I think. Right? If X does not tend to form cations easily, deduce what is X. This should be a non-metal oxide. Non-metal oxide means this should be group 15. Group 15 means nitrogen, phosphorus, arsenic, antimony, and bismuth. Right? It doesn't form cations easily. That means it's a non-metal. So it might be nitrogen. X does not react with oxygen easily, then identify X. Or the X nitrogen doesn't react with oxygen easily because there's a triple bond. There's a triple bond. It's difficult to react. Nitrogen. You have to have lightning. Lightning. When you have lightning, only nitrogen actually react with oxygen. Right? So it doesn't react. So it's nitrogen. Identify nitrogen. Draw the variation of the first 7 ionization energies of element X. So what is that? S2P3. Nitrogen is S2P3. So you remove the first electron, second electron, third electron, fourth electron, fifth electron, sixth electron, you have a higher energy, seventh electron. So this is how the variation takes place. Right? After removing 5 electrons, When you remove the sixth electron, you have a higher value. Show the arrangement of electrons in the valence shell of element X. So what is the configuration? S2p3. S2p3 is how the elements arrange. If you look at this one, if this is the nucleus, you have 3 electrons here and then 2 electrons in the sub-energy level. This is the main sub-energy level. S, you have to local, I mean, we don't draw this one. You just have to say S2P3 කියලා තියෙනවා. Okay, so 30. But I'm just looking at the answers that you have. We can reason it out as ZEFF is higher than sodium? Oh yeah, that's okay. It says effective nuclear charge is the number of protons minus the screening effect. So that is okay. Can we draw diagrams in the essay questions if it is hard to describe the word? ඒක හරියට describe කරන්න ඕනේ. ඉතින් there are some words that they will look for. එතකොට මේ words වලට තමයි කට්ටිය දෙන්නේ. So you can draw a diagram, but you need to put the right words. They give marks for these words also. ඒක ඉතින් don't worry. ඒක when you practice this gradually, you will become better. එතකොට ඕකෙන් පුතා we have finished the entire unit number 1. All the tutorials I have given you, I have discussed them. Tutorials ඔක්කොම discuss කරලා තිනවා one after another. හරිද? දැන් it is all done. හරිද? I'll give you maybe another 2 weeks to study the entire material. හරි? ඊට පස්සේ starting from next week I will start the tutorial number 2 in bonding. හරිද? bonding වල tutorial එක I will start discussing them. I think it's easy. It looks little difficult. Our first unit it looks little difficult. But if you gradually work it out, it can take a කාලයක් යනකොට when you start doing SPD, this will revise and you will become better at it. But only thing is you need to revise it one time, right? Before now we go on to the next one. හරි? ඒක බලන්න. Next week we will work it out. When XF3 combines with fluorine, we consider the valency of fluorine. Oh, yeah, I think XF3 when XF3 combines කියලා නෑනේ. When X combines with fluorine, it gives you XF3. Fluorine has a valency of 1. It only has a 1 valence in එකයිනේ තියෙන්නේ. එතකොට එහෙනම් මේක valency අනිවාර්යෙන්ම 3. Valence is 3. හරි. එහෙනම් අපි මෙතනින් I'll stop it and we'll meet on Saturday. And we'll do more materials, right? Thank you, Buddha. Right, bye. Right, thanks for joining. Right, take care. Bye.